In this tutorial, let's discuss the programming question, find the difference. So let's first understand the problem statement. So in this problem, we have given two strings S and T, which consists of only lowercase letters. So string T is generated by random shuffling of string S and then added one more letter at a random position. We have to find the letter that was added in string T. For example, so in this example, you can see a string S. In a string S, there are four letters A, B, C, D, and string T is generated by random shuffling of string S and then added one more letter at a random position. So all the letters of a string S and string T are same except E. So E is the output. So this is the problem statement. And now let's discuss multiple approaches to solve this problem. Let's start with the easiest approach, and before solving a problem, let's focus on the objective of a problem. So in this problem, we have to find one character which is added in the random position in a string T. So all the character in both the strings are same except one which is added in the random position of string T. So we have to find that character which is added in the random position of string T. So in this example, I am using a hash map to solve this problem. So I have first traversed this string and created a map of character and its count. And then I have traversed this string T and checked which character is not present in a map. So let's visualize this approach. So let's create a hash map. So hash map is nothing but a key value pair. And in this case, so the key is the character and value is its counts. And why we are considering the counts, so you will understand shortly. So first we traverse this string and put them in a hash map. So first character is A. So A is not present in a hash map, so we put A and its count 1. So you can see this line of code where we put the character and here we are putting its value. So before putting its value, we are checking whether this character is already present in a map. If it is, then give me its previous count, else consider the default value which is 0 and then add 1 to it. So get or default method does this thing. Then we take this character B and again the same thing, we put them in a hash map. Then similarly with C and then with D. Now we are done with this traversal. Next step is to traverse this string T and check which character is not present in a map. So first A. So A, when we check in a hash map, we check whether this key is present in a hash map. Yes. If its count is greater than 0, yes. So it means we have to take this character and decrement its count and then put them back in a hash map. And why we are doing it, you will understand shortly. So now the new value is put here, which is 0. Then the next character is B. Again, the B is present in a hash map. We take and its value, its count is greater than 0. So we take this key, decrement its value, which is here we are doing it, and then put them back in a hash map. Similarly with C and D. When E comes, we check in a hash map, is this key present in a hash map? No. So we return this character. So this is the character which is added in a string T, and if none of the case is true, we return this empty character, which is not the case, but we have to return some character value as this function require to return the character. And now let's discuss why we are considering the count. Now suppose instead of A, B, C, D, E, what if this T is A, B, C, D, A? Now in that case, all the characters are same. So A, B, C, D is also present in string S and A, B, C, D is also present in string T. Only the frequency differs. Here A occurs once, here A occurs twice. So when we take the character and its count, we decrement it and put them back in a hash map. When again this character comes, we see this key is present, but its count is equal to 0, it is not greater than 0. So it means this is the extra character which is added in string t. So that's the logic behind why we have considered character and its count. So this is the one way to solve this problem. Now let's talk about its time and space complexity. So its time complexity is big O of n, and so this both the string consist of lowercase letters. It means at max we always use 26 characters. So if we take the array of size 26, it means it is always constant, it always uses the constant space. So here we have used the hash map, but it always uses the constant space. So its space complexity is also big O of 1. So that's the first that's the easiest way to solve this problem. Now let's discuss our second approach. Let's discuss a very interesting solution of this problem. So as per the problem statement, we know in both the string all the characters are same except one character which is added in string t. So it means if we subtract, or if we take the sum of the subtraction of sky value of all the characters of a string t with string s, will leave us the sky value of the extra character, and that's what we want, and that's the solution of our problem. So let's visualize this problem. So what I'm trying to say is, let's declare one sum variable which is initialized with 0, and let's start traversing a string, both the strings simultaneously. And we know in a string t there is so if the length of a string s is n, then the length of a string t is n plus 1. There is one extra character in a string t. So let's traverse both the string. So what, and we have declared one sum variable. So what's the sky value of small case letter a? So it is 97. So let's subtract a minus a. So and its subtraction is 0. So we add 0 to the sum, it's still 0. Similarly with b, and similarly with c. So their sky value is 99. 99 minus 99 is 0. D, their sky value is 100, and it is 100 minus 100 is 0. Now we traverse till the string. So the length of string s, as we know, there is one extra character present in a string t. So when we came out of this loop, we take the value sky value of this character, which is e, and add it to the sum. So the sky value of character e is 101. So let's add them to a sum variable, and we typecast them into a character and return the character which we get when we typecast this int into a character type. So we get e. So this is a very interesting problem. So we know, in both the strings all the characters are same except one character. So when we subtract with the sky values, so the result will be 0, except the value of sum will be the extra character which is present in a string t. So now let's talk about its time and space complexity. So its time complexity is big O of n, and its space complexity is big O of 1. So let's discuss our last approach to solve this problem. So in the last example, we are using the property of XOR to solve this problem. So the property of XOR is, if we do the XOR of two similar number, it will cancel out. So it means when we do the XOR of all the ASCII value of string s with string all the character ASCII value of string s with the all the character ASCII value of string t, we are left with the ASCII value of extra character which is added in string t. And when we typecast them into character and we return them, we get the result. We get the extra character which is added in string t. So let's understand the property of XOR. So let's say we start with character a. So the ASCII value of character a is, small character a is 97, and when we convert them into the binary representation, it will be this and this. It will be represented in this form. And again in T also it is A. So when we do, again let's write them into their binary representation. And when we do the XOR of two similar bits, it will give you the 0. And when we do the XOR of two different bits, I mean XOR of 0 and 1 will give you 1, and XOR of 1 and 1 will give you 0. So basically when we do the XOR of these two bits, we get 0. And again all the bits are same, so we get 0 0 0 0 0. So we get 0. It means two similar numbers are cancelled out. So when we traverse both the string and we take the ASCII value of each character, so it will be cancelled out, as all the characters in both the strings are same except one character. So we are left with only the ASCII value of different character. And when we typecast them into a character, so we are left with 101, and when we typecast them we get E, and we return this value. So this is the logic behind using the XOR operator. Now let's discuss its time and space complexity. So its time complexity is big O of n, and its space complexity is big O of 1. So that's it for this video tutorial. In this tutorial I have explained 3 approaches to solve this problem, and if you know any other approach to solve this problem, you can let us know through your comment. And for more such programming videos, you can subscribe our YouTube channel. You can visit our website, which is https://webrewrite.com. Thanks for watching this video.